Now that we have delved into the intricacies of Spring WebFlux and explored the fascinating realm of Java virtual threads, it's time for the moment that we have been waiting for, a hands-on comparison of their performance in action. But before we dive into the live demonstration, let's just recap a bit first. So Spring WebFlux, as we know, it offers reactive programming capabilities and it enables asynchronous and non-blocking operations. Whereas the Java virtual threads, they provide lightweight concurrencies and allow thousands and thousands of threads to coexist without overwhelming any system resources. For our experiment today, we have set up a Postgres container with a lakh employee records in an employee table. We would subject this data to 3 different setups to gauge their performance. So the first up, we would have a traditional threading model, the Spring MVC with the traditional or the OS threads. This would serve as a baseline for comparison. The next, we would have the star of the show, which is the Spring WebFlux, the reactive contender with its non-blocking architecture, and it promises to handle the hefty workload with ease. And last not the least, we'll introduce the new contender, which is the Spring MVC with the virtual threads. This setup will showcase how virtual threads tackle the load and shaking up the potential expectations. Now, I don't know about you, but I would be waiting to see these results. Will the traditional threads struggle to keep the pace, or will the virtual threads and the reactive programming steal the spotlight? The stage is set and the anticipation is on. So let's dive right into it and uncover the truth together. So here we are with the code setup. Before we delve into the code bases of the Spring MVC and the Spring WebFlux, let's first see how the local setup or how the Postgres has been set up. So we have the Docker compose for the Postgres, wherein we have this environment which wherein the username and the password is the Postgres and Postgres, and there is a DB which we have created, which is the employees DB. And with this we also have a script, Postgres script, which actually builds the DB with more than a lakh records of the data. So let's see the script. So we create an employee table with the required columns and we insert a lakh records into the table. So it's a simple script wherein you insert into the employee table with an ID column and the random text and random salary, and you generate the ID column from 1 to 1 lakh. Let's run this part of it. So let's see whether we have Docker running. Yes, we have Docker running. Now let's go into the local setup and let's try to do the setup.sh. So with this, it will try to do the Docker compose with the Docker compose file, and here our setup is ready and working. To check this, let's see the system. Yep, we have our Postgres setup ready to go. Now, once we have the Postgres container ready, let's see the first part of the comparison, which is the Spring with the traditional MVC. So here we have, if you go and see, we have the traditional Spring Boot web, and we have the other configured dependencies of the Spring Boot, which is the Spring Boot JPA and the Postgres container, the PostgreSQL. If I go into the code base, let's first see that what we have is a simple app, Spring Boot app, which has a controller, which is the employee controller, and it has only one get endpoint right now, which works on fetching the employee details based on the given employee ID. So how it does is that it has a employee service and it fetches the employee from this employee service using the DAO. So there is a DAO, we have a simple DAO, which is a JPA DAO, and it based on the ID, it will find the employee. it's a simple query which says that select from the employee table wherein the ID equals to the given ID. Now let's try to run this particular piece. So before we run it, we also see what are the parameters that we have given to this Spring Boot application. So our server is running on port 8084 and we have this JDBC URL for the Postgres, which is in the local host. 5432 is the port and this is the database, as we have already specified 5432 in our Docker Compose file. Now we also are using a connection pool with a pool size of 100, and there are two init and test queries for the connection, which is select one so as to maintain the connection, and we have a PostgreSQL dialect in the JPA. That means our backend database is Postgres and not MySQL or MS SQL or any other ones for this JPA to work. Now let's try to run this part of it. So our application is now started. Now let's go to the browser and check whether our application is performing as what we have expected it to do. So let's go to the browser, and since our server was on the endpoint, let's see for, let's say, employee 1. Yep, it is giving you employee 1 with some random data. Let's go and check for, let's say, employee 100. Yep, it is providing you with the employee ID 100 with some random data, which is perfect. Now let's come back and try to stress test this. So in order to stress test this, we'll be using Locus, which is an open source software which provides you a web interface for stress testing. The Locus file, if we come and see it, what it will be is that we are creating a Locus file with an employee user and with a task defined under it. The task is nothing but we are choosing a random integer between 1 to 1 lakh, which is your employee ID, and we are calling the get employee endpoint with the employee ID of the service, and we'll see how this particular thing functions. So in order to run Locus, let me just come back to my terminal and let's run the Locus command. With it says that Locus -f the Locus file, so all the Locus files under this particular folder will be picked up and it will pick the classes under it. So let's first click it to start. Oh, it started very fast. Let's go back to the perfect. We have a employee class. Let's take around 1000 users with a spawn rate of 100, and let's hit the host 8084 with it, and let's run it for 5 minutes. What this configuration says is that total we'll have 1000 users running at peak, and we'll start the users at a spawning rate of 100, which means that every second 100 users are added to the pool of the users that are hitting the service till they reach the 1000 mark. So that means in 10 seconds this particular service would have all the users hitting the service. So let's kick off the test. When you come to the chart, so we now have 1000 users that are hitting the service endpoint. If you see over here, there are 1000 users running, and the request that it can serve is around 230 238 requests per second our service with 0 failure rate, and the 50th percentile now has become 2500 milliseconds, which is around 25 seconds, and the 95th percentile, or 95% of the times, the response is coming within 3300 milliseconds, and there are no failures around it. So this is our benchmark with the traditional OS threads that our service is performing around 200 to 230 milliseconds. Let me stop this thread. Perfect. Let's get back over here and let's stop the Locus server. Also, let's stop our application. Now we have the second contender, which is the Spring WebFlux. Over here, if I come and see the POM, what we are using is all the reactive paradigms. So over here we have the Spring Boot starter, the WebFlux one right now, with the data being the Spring Boot R2DBC, which is the reactive paradigm of the database, the calling the database. And we have also included the R2DBC PostgreSQL dependency. And of course, with this thing can only run the R2DBC when you have the reactor core dependencies as well. So we have added those reactor core dependencies. And if I come and see it over here, again, I have an app.java, which is a Spring Boot app with a controller, which is just similar to the get employee controller. But over here, we are still taking the employee ID as the input, but we are returning the mono of the employee ID, which is the standard format of the Spring WebFlux. And the way it is working is it is calling the fetch employee service endpoint, and which in turn calls the DAO of the employee. This DAO is now the reactive CRUD DAO or the R2DBC DAO, wherein it is finding the employee by its ID by calling the select star from employee, where the ID is equal to the employee ID, and which is returning the mono of the employee. And the way it is running is, again, if I see the server is now at port 8080 and the R2DBC endpoint is using the Postgres localhost endpoint with the employees as the DB. The username and the password is Postgres, and we again have a pool of 50 initial size and the max size being 100, and this pool is enabled with a validation query of select one. So let's try to run this particular application, which is the WebFlux one. So our application is now started, and let's try to check this thing by hitting the endpoint of the application. Now it's starting on 8080 port. So let me change the port and see whether it is returning the result. Yes, it was able to return the employee ID with 100, and with 1 also it's working. And let's change it to, let's say, 50. Perfect. It's working with all the 3 employee IDs. Now let's again run the locus server and test it again. So this was our locus server. I'm still running the locus server again. So the locus server is started. So going back to the locus, we again have the employee class. Now we'll keep the same configuration as number of users as 1000 with a spawn rate of 100 users per second, but this time we'll be calling the 8080 endpoint, which is of the Spring WebFlux, and we'll have a runtime of 5 minutes. And we'll say now the test has started, and if you can see, the WebFlux is able to handle a load of around 368 to 350 requests per second, which is pretty amazing, and it's increasing. So if it's gone to 414, 450 requests, and it's going to 500 requests per second, or it's even coming down now and going back up and to 453, 397. Yeah, I think we should take around 350 requests, somewhere around 350 now. As in when it's stabilizing, it's coming around 350 now. Let's park it with 350 to 370 requests per second is what it is doing. So I'll stop this thread thing. I'll also stop the locus, and I'll stop the application. Now with the Spring virtual threads that were introduced in Java 21, so let's come back over here, and as we can see, our version is Java 21. So what is the change that we need to do? As I told you earlier, that the changes are very minimal. So if I come back to the main app.java, if you see, we had this application and it's a simple Spring Boot application, and if I reduce this part, it's just this. So we just have to change the protocol handler for the Tomcat, and we need to say that instead of the default executor, we need to have a virtual thread factory executor. That's it. We just need to do this much change and rerun the application. Our application is now started, and let's come back to the locus and rerun the locus as well. So the locus is also now started, and let's run and go back to the browser. And again, with the employee class, we'll have the same configuration of 1000 users and spawn it as this. Again, the URL is 8084, which is the URL for our traditional OS application, but now with the virtual threads coming in place, and the runtime again becomes 5 minutes. And let's start the test. So it started, it's around 204, goes to 273, beating the virtual threads, or sorry, the traditional threads. and it's gone to 413, 445, 447, 460, around 447 now, 438, going back to 450, 458, 466, and it's stabilizing at 467, 460. So it's working pretty much better than the Spring WebFlux. So basically, as we saw, the Spring WebFlux, the traditional hedge is had a RPS of around 240. The virtual threads, the WebFlux, had an RPS of around 370, and the virtual threads has an RPS around 430. And if I go back, the TP 50 and 95 were 2400, sorry, 2400 and 3400. The TP 50 and 95 over here were, I think it was 2200, or it was, sorry, 2400 with 2700, and the TP 50 and 95 are, let's go back and see, that's 1600 and 1900. My god, it's super fast. And everything is in milliseconds. It's quite surprising that the virtual threads are having much better throughput and latency than even the WebFlux or the reactive paradigm, with the complexity just being you just add one line of code. That's it. And this brings us to the end of the journey. What a journey it has been. I hope you enjoyed diving into the world of Spring WebFlux and Java virtual threads with me today. As always, it's been a pleasure sharing all these insights with you. Remember, at my channel, my mission is to help you guys grow and thrive in your software development journey. Whether it's through tutorials like this one, or even deep dives, or complex concepts, or even simply staying connected with our vibrant community, I'm here to support in every step of the way. So keep coding, keep learning, and keep pushing the boundaries of what's possible. Together, we're gonna continue to shape the future of technology and make our mark on the world. So if you found this video helpful, don't forget to like, comment, and subscribe to the Systems Craft by Keshav for more insightful tutorials and such tech discussions. Thank you for being a part of this incredible journey, and until next time, happy coding. Bye bye.